All right, today we're going to talk about Lewis structures and review how to draw them. And so we remember we had a couple of simple rules to go over that I'll go over here at the beginning, and then we'll go into some practice. So the first rule is when you're drawing a Lewis structure, the first thing to do is to make sure that you count the number of electrons. And this is important. A lot of people get in trouble because they skip that first rule and end up with the wrong number of electrons in the structure. So remember that each atom is going to contribute a certain number of valence electrons, and you may have to adjust the number of electrons if your species is an ion by adding and subtracting to account for the total charge. Secondly, what we're going to do is we're going to construct a skeletal structure connecting all of the atoms using single bonds. Each single bond is going to use 2 of the electrons. And then if there are any electrons left over, we'll put them in as non-bonding pairs. Okay, so let's try that. As an example, let's start with methane. So methane has the formula CH4. And so let's count the electrons first. The first thing to do is to note that carbon is going to give us 4 electrons. We can see that from the periodic table. Carbon is in group 4A in the older nomenclature. And hydrogen, there are 4 hydrogens. Each one will give us 1 electron. That gives us a total of 8 electrons. And so now the next step, once we've counted the electrons, is going to be to arrange a molecule by connecting the atoms using single bonds. And so I'll put the 4 hydrogens on the outside of my structure, and each single bond is going to use 2 electrons. So I've used 2, 4, 6, 8 electrons. I had 8 total. I have no more electrons left. So this is the finished Lewis structure for methane. I didn't have to do anything in terms of non-bonding pairs. But let's try another example. This example is going to be ammonia. And ammonia, let's count the electrons. Nitrogen is going to give us 5 electrons. And then the hydrogens, there are 3 of them. Each one gives us 1. Once again, there are 8 total electrons. We can now build the structure using a skeletal structure that looks like this. And I've used 2, 4, 6 electrons. I have 2 remaining, and I'm going to put them in as non-bonding pairs. Now, since all of the hydrogens already have 2 valence electrons, the only place I can put the non-bonding pairs is on the nitrogen. And now the nitrogen has 8 electrons in its valence shell, and this Lewis structure is completed. One more example is water. So again, for this one, there is an example. Let's see here. Let's count the electrons. Oxygen is going to give us 6. Hydrogens, there are 2 of them. Each one will give us 1. Again, that is 8 total. Not all molecules have 8 valence electrons, but this set of examples, they all do. Now I'm going to connect the electrons, or connect the atoms using non-bonding pairs, each non-bonding pair using 2 electrons. So I've used 4 of them. I have 4 remaining, and those 4 remaining electrons are going to go in as non-bonding pairs on the oxygen. And now the oxygen has its Lewis octet. The hydrogens are satisfied. This is the final Lewis structure for water. So next time we'll talk about what happens when there are extra electrons or not enough to fill the octets.